Assalamualaikum, morning, good afternoon, good evening, good night. This is VKU2 333. In chapter 5, we will discuss about transmission parameter for today. Right, let's look at the two-port network, which is linear. We have V1 and V2, I1 and I2, and notice that I2 is negative in the direction of the current. And we assume no independent source exists in the network. And we have these two equations, V1 equals to A V2 minus B I2, and I1 equals to C V2 minus D I2. If we arrange it in this form, we'll get the parameters A, B, C, and D, and this is what is called transmission parameter. T is transmission parameters, simply T. The people call it A, B, C, D, and each parameter has different units. Transmission parameters are useful in analyzing transmission line cable fibers because they express sending end variables V1 and I1 in terms of receiving end variables V2 and negative I2. The set of parameters relate input and output are shown as V1 equals to A V2 minus B I2 and I1 equals to C V2 minus D I2, or in the matrix form ABCD. And these can be determined, ABCD can be determined by A equals to V1 over V2 and I2 equals to 0, B equals to minus V1 over I2, V2 equals to 0, C equals to I1 over V2 and I2 equals to 0, and D equals to minus I1 over I2 and V2 equals to 0. A is open circuit voltage ratio, which is dimensionless. B is the negative short circuit transfer impedance in ohms. C is the open circuit transfer admittance in Siemens. D is negative short circuit current ratio, which is dimensionless. Alright, we're going to start expressing the transmission parameters in terms of the Z parameters or the impedance parameters we've learned before. And we know that this is the equation for the impedance parameters. V1, Z11, I1 plus Z12, I2 and the rest. And from equation 2 we can rearrange the equations to become I1 equals to 1 over Z21 V2 minus Z22 over Z21 I2. And by putting equation 3 inside equation number 1, we can obtain V1 in relation to V2 and I2. And we know that the determinant of Z is Z11 Z22 minus Z21 Z12, and we'll get V1 equals to Z11 over Z21 V2 plus I2 minus determinant over Z21, which is equation 4. And the basic for transmission parameter is V1 equals to A V2 minus B I2. So when we compare these two equations, we can see that you'll get A equals to Z11 over Z21, B equals to determinant of Z over Z21, C equals to 1 over Z21, and D equals to Z22 over Z21. So if you try to express the transmission parameters in terms of Y parameter, we'll use the equation for the Y parameters or the admittance parameters. I1 equals to Y11 V1 plus Y12 V2 and the rest. And if we do the same way that we modify the equations, in the end we will get I1 equals to minus determinant of Y over Y21 V2 plus Y11 over Y21 I2. And comparing this with the T parameters, we can actually get A equals to Y22 over Y21, B equals to negative Y1 over Y21, and C equals to negative determinant Y over Y21, and D equals to Y11 over Y21. Alright, let's try out an exercise. Let's obtain the transmission parameters for network below. 3 resistances in the network. We have 2 ohms, 4 ohms and 6 ohms. And we know that the basic for the transmission parameter is V1 equals to A V2 minus B I2 and I1 equals to C V2 minus D I2. Now the solution to that is we'll attach a voltage at port 1, and we'll open circuit port 2 so it becomes as shown in the diagram or figure A. And A is simply V1 over V2, so we know that V1 is the voltage of the 2 ohms plus the 4 ohms voltage, and V2 is just the voltage across the 4 ohm resistor. And doing that, we will get A equals to 1.5, and for C it is I1 over V2, and I1 is I1, V2 is the voltage across the 4 ohm resistor, that is 4I1, and thus 1 over 4 will make it 0.25 Siemens. For B and D, we'll just attach a voltage source at port 1, and for port 2 we'll short circuit to make the voltage port 2 equals to 0. And by doing that, we can get I2, which is minus 4 over 10 I1. So I2 is the current divider, and it is the opposite direction of I1, so that's why it's negative. And we rearrange that, we'll get D equals to minus I1 over I2, and that is 10 over 4, which is 2.5. Right. So for V1, we know that it is impedance 2 in series with 4 and 6. That will give us 4.4 times I1. And for B, it is simply minus V1 over I2. So minus V1 is 4.4 or minus 4.4 I1, and I2 is minus 0.4 I1, and that will make B to become 11 ohms, right? So in the end, we have the transmission parameter as 1.5, 11 ohms, 0.25 Siemens, and 2.5. So that's how we obtain the ABCD parameters, or the transmission parameters. Thank you, and all the best for your final exam. See you.